All right, here's a diagram. I'm gonna do this a quick way, and then I'll talk about it a little bit more slowly. So let's just say, for example, that the side length here is 2. Then, these two have exactly the same side length because they have a shared one. So this is going to be 1, and this is going to be 1. Therefore, the side lengths of the hexagon are in the ratio 1 to 2, the smaller one to the larger one. Now that's the length ratio. For the area ratio, you then just square both. So we're going to get the answer 1 to 4. Now, just let me explain why we square both, because essentially we're timesing all the lengths. So a simple example is to look at a square. And if you have 1 and 1, the area is just 1. When you have 2 and 2, because you're doubling the length in this dimension, but also this dimension, then you're going to double the area as you stretch it one way, but then double it again as you stretch it the other way. That's why we're going to get 4. And the same is happening here, essentially. We're doubling the base, we're doubling the height, and that's the key thing. So ultimately, that's going to quadruple the area. If it's really worth learning that basically the length scale factor, the area scale factor, and the volume. If you did have a volume of similar solids, then you would cube the length scale factor to get the volume scale factor. One of the way of dealing with this question, if you're not familiar with that, is we could split it into equilateral triangles. I'm not a big fan of this for this sort of question, but it should work. Okay, so I've got an equilateral triangle here, and I could actually split that equilateral triangle into lots of little triangles. So you can see I could make it look like this. And if I do the same over here, okay, these are all the same size. So I've got 6 little equilateral triangles here, and I've got 4 here, but then it's going to be 4 times 6 because there's 6 of these. So it's going to be 24 here, and so it's going to be 6 to 24, which again we can divide through by 6 is going to give 1 to 4. So yeah, that does work. You got to know that you can split it into equilateral triangles. So to be honest, I'd say like try. It's useful for other questions actually. So I wouldn't like write this off, but in this case, it's much more just quicker if you can learn this sort of area idea, area scale factor concept.